Today we're going to be doing the first part of 5.3. That's why we're calling it 5.3a. It's evaluating and classifying polynomials. All right, let's begin looking at our notes. What is a polynomial? Well, you could read the instructions right there. But it's simply, the word poly means many, right? Poly means many. So it's a variable expression with many terms. Any variable expression is technically a polynomial. If it has variables, math operations, and numbers, it's technically a variable expression. It's technically a polynomial, but it has to only have a certain type of variable. So, for example, like 3x to the fourth power minus 2x plus 5. That's a polynomial right there, okay? But if you had x to the fourth and then a y right here, that would no longer be a polynomial, okay? Or if you had like out here at the end plus 5, and let's say it was divided by x, then that's no longer a polynomial. So there's a couple of rare cases, but for the most part, let's just remember that a polynomial, as it says right there on the instructions, is a variable expression with many terms. As a matter of fact, let's jot this down right here on the side. That for sure is a polynomial. It has many terms. How many terms does it have right there? That is right. It has 4 terms, definitely a polynomial. How do you know how to count terms? Well, the pluses and the minus signs separate them, right? You have one term right here, the 2x. You have another term right here, the minus x to the third. Another term, the minus 4. And another term, the plus 5x squared. That's 4 terms. That's definitely a polynomial. It has many terms in it. Let's go back to the vocab list. And you know what? We're going to be jumping back and forth with this problem right here as we go through the vocab. The second word on our notes is the degree. And we're not talking about college degree here. We're talking about the highest exponent of a variable expression, or the highest exponent of a polynomial is the degree, right? So degree, the highest exponent of the variable or variable expression. Technically, it's the highest exponent of your polynomial. So we just jotted down the polynomial, that nasty polynomial right there. What is the degree of that polynomial? Okay, that's the term, yeah. And the degree is just the highest exponent. What's the highest exponent you see? 3. So that's it. There's your answer. The degree is 3. Believe it or not, there's going to be a question like that on the homework tonight. There's going to be a question like that on the test next week. That's like a free point, right? You just look at it. What's the highest exponent? Boom, that's your degree. Simple, right? Okay, let's go back to the vocab, and we're going to keep jumping back and forth. Standard form. We did many forms back in last semester when we graphed parabolas, right? You guys remember standard form?
Yeah.
What was standard form from back then?
Like the exponent had to be like lined up, so 4, 3, 2, 1.
Okay, yeah, standard form, highest exponent down to smallest. And I was anticipating you guys not to remember that. So just to remind you, we had different types of forms last semester when we graphed parabolas. Vertex form was a parentheses x minus h close parentheses squared plus k. We learned a lot that the a value, if it's positive, it opens up. The parabola would go up. If it's negative, it would open down. The hk, that was the most important point, the vertex. This is not really important for today's lesson, but it is definitely important last semester, and it will be important in the future. So if you totally forgot about that, it'd probably be a good idea to jot that down again. And more importantly, standard form, because today we're going to be dealing with standard form, but not just of quadratic trinomials like you see here, but standard form of any polynomial. And just like you said, standard form is writing it in order from the highest exponent down to the smallest, down to the constant at the very end. The constant is the number that has no variable, okay? Anyway, right here, standard form. It says a polynomial written in order from the largest exponent down to the smallest with the constant at the very end. We could actually even jot that down. Okay, with the constant at the very end. Anyway, let's go back to the problem that we just jotted down, and let's rewrite it in standard form. So here's the problem, and how am I going to ask it? I'm going to ask rewrite in standard form. That's going to be the question on the homework tonight. It's going to be the question on the test next week. And again, it's like a free point. All you got to do is organize it, highest exponent down to the smallest with the constant at the very end. So what's the first term I should write?
Negative x.
Yes, negative x to the third, right? Now, the minus sign belongs to it, so you have to put that minus sign with it. That's the highest exponent. That's great. What's the next term we should write?
Plus 5x squared.
That's right, plus 5x squared. All right, great. And after that?
Plus 2x.
Plus 2x. Even though it didn't have a plus, it's positive, so you put a plus right there. And then minus 4 at the very end. That's right. Minus 4. And that's it. That's like another free point on the test next week, right? Anyway, standard form. Let's go back to the vocab words. Leading coefficient. Well, let's begin with the word coefficient. What does coefficient mean? That's the number that tells you how many of that term you have. It's the number in front of the variable. So, for example, if I have 5x, the coefficient is the 5. The variable is x, right? So coefficient is the number that's in front of your variable, okay? So what is leading coefficient? Leading is like if you're leading the race, you're out in front of the race, right? You're winning the race. If you're leading the parade, you're out in the front. You're the leader, right? So what is a leading coefficient? It's the number that's out in the front when it's in order, in standard form. So if we read that definition, the coefficient, the number that's out in the first term of a polynomial that's in order in standard form, highest exponent down to smallest. So another question I could ask is, what is the leading coefficient? And somebody already said it. What's the leading coefficient? Negative 1. Now, I probably won't write it for you in standard form. I'll probably write it like this red one, and I'll say, what's the leading coefficient? And if you're not paying attention right now, you're probably going to say 2, and that's going to be wrong, right? In order for you to see the leading coefficient, it has to be in order. Then you could look at the number out in the front, okay? So that's another easy question on next week's test. These are all like free points, ridiculously easy, right? Last but not least, the constant term. So if somebody's constantly bugging you, they're always bugging you, they don't change, right? Constant means that it does not change. What doesn't change? The 5 does not change, right? It's always going to be 5. It never becomes 7. It never becomes 10 unless it has a variable. Then it will vary, right? This could be a 5 if the x is 1. This could be a 10 if the x is 2. But the bottom line here is a constant is simply a number without a variable. And when it's in order, it's the number at the very end. So back to the example we're working with. If I ask you for the constant term, what's it going to be?
-4.
That's right, -4. Another easy question on next week's test. Ridiculous, right? Super easy. So we got to practice these words. Degree is the highest exponent. So what's the degree here? Oh, it's 3. Rewrite it in standard form. Yeah, it has to be the highest exponent down to the smallest with the constant at the very end. What is a constant? It's the number without a variable, right? Just the -4 or the +3 or the +7 or the -1, as long as it's a number without a variable. What's the leading coefficient? When it's in order, it's a number out here in the front. By the way, speaking of standard form, it does not have to have every single power represented. Last semester, you guys remember synthetic division?
Yeah.
You needed every power represented. So like, let's say we had something like x to the third minus x plus 4. With synthetic division, you would have to say you're missing the x squared. You don't have to, it doesn't matter if it's missing a certain value. As long as it has highest power down, smaller, down to the constant at the very end, this is still a standard form polynomial. Make sense?
Yeah.
Okay, so who cares if there's missing values? We're not doing synthetic division. Anyway, let's go to the rest of these notes. In addition to those vocab words, we need to be able to take any polynomial and classify it. That means give it a first and last name. So do me a favor, on your page of notes, box this in right here and write first name. We're going to give them a first name based on the degree. And then box this one in, and we're going to give it a last name based on the number of terms. Okay? So the first name is going to be based on the degree. If your highest exponent is 2, then it's going to be called quadratic, right? Last semester, we were graphing a bunch of parabolas. Those were all quadratic equations because they all had x squared That was the highest degree, the highest exponent. But if your highest exponent is 4, you're going to call it quartic, highest exponent 3, cubic, highest exponent 1, linear. The last name is based on the number of terms. How many actual terms do you have? If it's only one term, it's a monomial. 2 terms, binomial. 3 terms, trinomial. 4 or more, that's a lot, that's many, polynomial. Okay? So, if I go to the original question that we've been doing, and I asked you classify it, in other words, let's go to this one that's already nice in standard form. If I say classify, what will the first and last name be? Cubic. That's right, polynomial. I'll abbreviate. Cubic because the highest exponent is 3, and on that list it says cubic is a power of 3. And how many terms? 1, 2, 3, 4. That's 4 or more, it's poly. So cubic polynomial. That's the first and last name. That will be on the test next week as well. Easy questions. Ridiculously easy questions. You know what? We just jotted this one down for funsies. What would you classify this as? Cubic trinomial. Great. For funsies, what's the leading coefficient on this guy? Just the number 1, right? What's the constant on this guy? Positive 4. See, you guys got it. Man, A+. Everybody's going to have an A+ by the end of today, right? Down here, we even have more examples nicely in a chart with the answers, of course, but don't look at the answers. Let's just, obviously, if you just have a number that without a variable, that's constant. You don't even have to classify. It's just the number 6. It'll always be 6. But right here, you do have a variable with the power. What's the power here? What's the degree? 1. How many terms do you have? 1. So you have a first name linear, last name monomial. Right here, what's your degree? 1. How many? So and how many terms? 2. So what do we call this? Linear binomial, right? How about here? What do we call this? First name? Quadratic trinomial, right? Quadratic, 3 terms, trinomial. What about here? Cubic binomial, right? Cubic binomial. How about this last one? Quartic polynomial, right? Yeah. All of these are in standard form. Every single one of these is in standard form, right? This one's in standard form. You have the power of 1, and over here the constant. This one's in standard form, power of 2, power of 1, constant at the very end. Even this one's in standard form, power of 4, power of 3. Even though the power of 2 is missing, who cares? It's still organized from highest exponent down to smallest down to the constant, right? What if this last one right here, let's just pretend that it didn't have this +1, and let's say I asked you for the constant. What would you say if it didn't have a number right there? What is the constant? 0. There is no constant, right? 0. All right, good stuff. That's like tons of free points on next week's quiz. You guys should be able to ace that. And it's going to be all over the homework tonight as well. We're actually going to turn in a homework assignment tonight. It's due tomorrow by advisory. But in addition to that, in addition to all those vocabs, let's you don't have to write down the word what is function notation, but I do want you to maybe flip the paper over and jot down this function g of x. What is g of x? It's x squared plus 1. And as you guys are jotting this down, I want to tell you that this is function notation. This is the name of this function. Like if you were to graph this on Desmos, to graph the parabola, you would type it in as y equals x squared plus 1. But g of x is just the name of this function, the name of this machine. It's the notation. G of x is x squared plus 1. Now, how do we evaluate a function? With function notation, they're going to tell you find g of 2. And please copy that down as well. Find g of 2. So we have our function g of x. Here it is. This is the machine. And on any machine, you could plug in any number you want and pull out any answer that you get, right, from plugging in. You have inputs, you have outputs. right here with function notation, they're telling you, I want you to go to the g of x function, and I want you to replace the x with 2 and to do the math. That's a really quick way of saying that. Go to your g of x function, plug in 2, do the math. Instead of writing out all those words, you could just say find g of 2. So let's actually find g of 2. Let's work this out together. Let's put g of 2 equals, the way to do it would be to go back to your original machine and replace whatever x's you have with parentheses. So instead of x squared, let's write parentheses squared plus 1. Instead of x squared plus 1, let's write parentheses squared plus 1. What are we going to plug inside the parentheses? The 2. That's right. So let's plug in that 2, and let's do the math. What do I do first? Do I do exponents or addition? Exponents. So what is 2 squared? 4. And 4 plus 1? 5. That is your answer, 5. G of 2 equals 5. Now that's like pre-algebra right there. Let's get a little more entertaining here. We're going to use that same function, g of x, but we're going to try to find g of 2x. Instead of plugging in a regular number, let's plug in a linear monomial into this quadratic binomial. I'm just showing off my vocab skills right there. But yeah, we're going to plug in the 2x right in there. And the safest way to plug in is to rewrite it with parentheses wherever you have your x. So instead of x squared plus 1, I'm going to write parentheses squared plus 1. And what am I plugging into those parentheses? 2x. So now let's do this. Now there's 2 ways of doing it. You could do it logically. 2x times 2x, oh, that's 2 times 2, and then x times x, that'll be 4x squared, right? Or you could use the rule of exponents, where you take that 2 and put it right on the 2, take the 2, put it right there on the x. You could distribute because there's no addition sign. It's a monomial. That's why we distribute. If it were a binomial, you would not be able to distribute. Anyway, 2 squared, x squared, what do we end up with? 4x squared. 4x squared with a plus 1. You cannot add 1. That's your final answer. You're done. There's your answer to g of 2x. That's still Algebra 1 stuff. We're still not in the entertaining section yet. How about we take that function g of x and let's try g of x plus 3. We're going to take the binomial x plus 3 and we're going to plug in that binomial, that linear binomial, we're going to plug it in right there with parentheses. So let's begin by rewriting it as x squared plus 1, but writing it with parentheses instead of the x. And let's now zoom into this, and let's plug in the x plus 3, that linear binomial they want us to plug in. Let's plug it in right there, x plus 3. Now, this is very different than the previous example we just did, because you cannot take the 2 and put it on the x, take the 2 and put it on the 3. That's incorrect. Big no-no. Why not? Because this is not a monomial. This is a binomial. So you actually have to write it out twice. X plus 3 times x plus 3. And distribute. X times x, x squared. X times 3, 3x. 3 times x is another 3x. 3 times 3 is positive 9. Don't forget about the positive 1 at the very end. Bring that down. This guy comes down. Now you still need to combine like terms. So let's combine the 3x with the 3x, giving us what? 6x. Bring down that x squared that's in the front. And let's also combine the 9 with the 1, giving us 10. So g of x plus 3, the answer is that quadratic trinomial. Quadratic because it has the power of 2, trinomial because there's 3 terms. I'm not even asking you to classify. I just want to keep up with that vocabulary so you'll get more comfortable with it. Are we good? Okay, and that's still Algebra 1, maybe second semester. Let's get to something that's more Algebra 2, more up our alley. Jot that down. We have this function. The other one was g of x. This one's called f of x. Nevertheless, it's done the same way. And we have 3x squared minus 4x. This is more Algebra 2 stuff here because we're not simply plugging in a number like 3 or like 5. We're actually plugging in a cubic monomial into the x positions of the f of x function. All right, so let's begin by rewriting our f of x function, but replacing the x's with parentheses. So here I go. 3x squared minus 4x. But instead of x's, I put parentheses. What am I plugging into those parentheses?
2a.
That's right, 2a to the third, right? So let's plug in 2a to the third into both of those parentheses. So when we do this math, you're not going to multiply first, right? You don't do the 3 times 2. On PEMDAS, what comes first? Parentheses, nothing to do inside of the parentheses. Exponents. We could do some exponents here. We have 2a to the third squared. You could think of it logically. 2a to the third times 2a to the third. 2 times 2 is 4. a to the third times a to the third is a to the sixth. Or you could actually distribute the 2, because it's a monomial, not a binomial. You could actually distribute. Put the 2 right there. 2 squared, that'll be 4. And put the 2 on top of the 3, power to a power, multiply, right? So what we end up with is 4a to the sixth. Are you with me? Okay, and that's barely the answer to 2a to the third square. We still have the times 3 out here in the front. So I need to take this times 3 and bring it down. And I might as well bring down the rest of this, the minus 4 times 2a to the third. So now that I've done exponents, now I can multiply. 3 times 4 is what? 12. A to the sixth power, that's right. And over here, negative 4 times 2? Minus 8. A to the third power. And that's all we could do. We can't combine these two terms because they are not the same. They're not like terms. This is a to the sixth, this is a to the third. Can't combine those. That is your answer for f of 2a to the third. So that's algebra 2 type of question. Here's an algebra 2 type of question that's even more fun, even more challenging. This one is the most entertaining question. So again, like always, let's rewrite the f of x function, but with parentheses instead of the variable x. So I'm going to rewrite it as 3x squared minus 4x. And we are plugging in the binomial a plus 3 into both of those positions. Now we got tons of work to do right here. Fun stuff with a capital F. That's right. We have a plus 3 to the second power. Again, you got to do exponents before multiplying. Do not distribute that 3. That'd be wrong. You can't multiply before dealing with exponents. So let's deal with the a plus 3 squared and write it 2 times. Again, you cannot distribute the 2. You can't make that an a squared and a 9 because it's a binomial, 2 terms. So if you have a binomial, you got to write it twice and distribute and combine like terms the way we used to in algebra 1, right? A times a squared. A times 3, 3a. 3 times a is another 3a. 3 times 3 is 9. We can combine the 3a with the 3a to give us 6a. What about that a squared in the front? Just bring it down. What about the plus 9 at the end? Bring that down. And that, ladies and gentlemen, is barely the answer to this. All right? I still have, so that's this in that parenthesis, in those yellow parentheses, that's barely the answer to a plus 3 squared. I still need a times 3 in the front. So I need to take this times 3 in the front and put a times 3 out there in the front. And it is important for you to actually put these parentheses here. If you don't put the parentheses, it's going to be wrong because you need to take that 3 and multiply it by the entire answer. Okay? So we're going to have to distribute that 3. Let's also take that minus 4 over here and just bring down everything. Minus 4 parenthesis a plus 3. So we're going to have to distribute the 3 into every single term, distribute the minus 4 into every single term, and then combine all the like terms. Like I said, this is the most entertaining question of the day. So here we go. 3 times a, that's 3a squared, or 3 times a squared is 3a squared. 3 times 6a is 18a. 3 times 9 is 27. And distributing the minus 4 times a is minus 4a. Minus 4 times 3 is minus 12. So we have a bunch of terms right there. It's a polynomial, but let's combine the terms that are alike. The 3a squared, this guy right here, you can't combine it with anything. So we're just going to bring it down as the first part of our answer, 3a squared. But what could we combine? We could combine this 18a with this minus 4a. And what do we get? Positive 14a, okay? And last but not least, we have a positive 27 with the negative 12. What do we get? positive 15, right? 15. Yeah, positive 15. 15. And ladies and gentlemen, that's it. What is f of a to the third? It's that answer, 3a squared plus 14a plus 15. Just for kicks, what is the coefficient of a? The coefficient of a. 14. What is the leading coefficient? 3. Is it in standard form? Yes. What's the constant? 15. Perfect. And that's it. That's it, guys.